Software testing is always a critical part of every development project. You probably learned some concepts about program testing in your programming class. However, sometimes as programmers we forget that the tests we run on our own code are only a small part of the overall testing scenario and testing requirements. It is not unusual for there to be problems when a new system is deployed. Sometimes there are serious problems which can inhibit the productive use of the new system. In most cases, these problems are caused by a lack of adequate testing. Because development projects are complex endeavors, they frequently get behind schedule, and because testing is one of the last steps in the project, it often gets shortchanged. In this video, we will discuss 4 of the most important types of testing that should be done in every project. In this figure, we see the detailed activities of Core Process 5 and 6. Core Process 5 consists of 4 major activities: program the software, unit test the software, identify and build test cases, integrate and test components. As you can see, 3 of these activities have to do with testing, which we will discuss in this video. Core Process 6 consists of these activities: perform system and stress tests, perform user acceptance tests, convert existing data, create training material and do the training, set up the production environment, and deploy the new system. The first 2 activities in this core process also have to do with testing. We will also discuss these 2 activities. So, as we know, testing runs through both of these core processes. Testing is always a key element of the success of every project. Let's define a few terms. Testing is that process of examining a component, a subsystem, or even the entire system to determine whether it operates correctly or not. There are 2 ways we can think about testing. First, one objective of testing is to find the bugs. Every new software component has bugs. Our job as testers is to find them and fix them. If you approach testing with this mindset, your testing will be much more thorough. The second objective of testing is to demonstrate and build confidence that the system does do what it is supposed to do, in every way and in every situation and for every business case. A test case is a somewhat formal description of a transaction that needs to be tested. As such, it will define a starting condition, the input events, and the final expected result. Defining and developing test cases is a complex endeavor. Test cases should be defined to test all the functional and non-functional requirements. Every use case should have several test cases defined. Test cases should be defined to test both the normal events and exception conditions or erroneous events. And then test data is the actual data that implements a test case. It consists of the beginning data in the database as well as the input fields and values. There are 4 types of testing that are most critical and should be a normal part of every project. Unit testing, this is testing in isolation. Integration testing, this is testing with the surrounding components. System testing, this is testing the entire system both for functional and non-functional utility. And finally, user acceptance testing. This is to allow the user to make sure the system meets the business need. In other words, is it fit for its purpose? We will discuss each type of testing. The objective of unit testing is to test a particular piece of software that is not influenced or impacted by the rest of the system. Unit testing therefore needs to be done in somewhat of an isolated environment. A unit test is the kind of test that a programmer does. When programmers write some methods for a class or for a group of classes, they should run a unit test using the transactions that execute those methods. These methods must perform correctly without any bugs when tested in isolation from the rest of the system. Often a programmer will need to utilize test drivers and test stubs. A test driver is a simple piece of code that will invoke the methods to be tested and will pass them the requisite parameters, both good and bad values, of course. A test stub is a simple piece of code that recognizes when it has been invoked. As shown in the figure, the blue box is the one being tested. It would normally be integrated with the green hexagons, but for unit testing purposes, a driver and stubs may be needed. The next level of testing is integration testing. In this level of testing, a component that tested successfully in isolation now must work correctly when integrated with other components. Integration testing not only tests a newly integrated component, but it also tests the entire unit or component working together. It tests such things as interface compatibility. It tests whether the integrated components can talk to each other correctly, whether the methods are called correctly and pass data in correct syntax and form. Parameter values, The passed and returned data must not only have the correct syntax and form, but it should also be within the correct range and correct values. Runtime exceptions are usually caused by conflicts in resource needs or expectations. For example, invoking a method on an object that has not been instantiated yet would cause a runtime error. And then finally, unexpected state conditions happen when the data is expected to have certain values, but it does not. For example, unless a sale item is in the ready-to-ship state, the system should not try to move it to a shipped state. When testing moves from unit test to integration testing, the level of complexity of testing increases significantly. Methods can be called from many different sources. When an error occurs, the tester must determine who was the calling object. All this makes integration testing more complex. The steps to perform integration testing are the following. First, of course, is to build the components to be integrated. Second, to create the test data that will test both the component itself and all of its interactions with the rest of the system. The test data should be saved for reuse as the system grows and for retesting. Save both the before files as well as the after files and the transaction files. Third, conduct the test. Fourth, evaluate the test results. In most cases, the test results should be predefined so that you know what to expect. And fifth, log the results. This is important for both those tests that ran successfully and for those that failed. Later on, you may need to refer to see what worked and when it worked. You may want to keep two logs, a log of tests and when they were run, and a log of errors that need to be fixed. And then 6, finally, correct the code, then rerun the tests. This often can take considerable time, but it should be done as rapidly as possible before other components begin to be integrated. This spreadsheet at the bottom of this slide is an example of an error log. Each error is numbered. It indicates what component is being tested, the date of the test, a description of the error, and its severity. The severity is how serious the error is. Next, its priority. Priority indicates how urgent it is to be fixed. Some errors can wait and be tested in the next round. Then information about who it is assigned to, when it is to be fixed, and when it actually was fixed. Sometimes the date of the retest is also included. There's space allowed also to describe the error in a little more detail. By system test, we mean an integration test that includes all the portions of the system, the entire system. The difference between this and an integration test is that the test data is more comprehensive and tests all the components of the entire system. It should be done on a regular basis. Performance and stress tests is a type of test that tests the non-functional requirements, such as the response time and throughput. This type of test is different because usually large volumes of data are required, as opposed to varied and different types of tests. Usually this type of test is done towards the end of the project when elaborate test cases are available and typical equipment can be used. User acceptance testing is, as the name implies, primarily a testing of the functional requirements to see if the new system satisfies the user's needs and the business requirements. This is sometimes called a test of the fitness for purpose. It is to see if the system actually solves the business need for which it was originally identified. The primary responsibility for this test should be with the users. They should take the lead because they are the ones that must be satisfied that it meets their requirements. However, in most cases, the users are not trained nor conversant with all of the ins and outs of the new system, and they will need heavy support from the testing and development team. Thus, both users and developers must cooperate and collaborate extensively for this type of testing. Because its purpose is to test fitness of purpose, it is usually done near the end of the project when the system is complete or mostly complete. Even though the UAT is performed toward the end of the project, planning needs to start early in the project and runs throughout the project. As use cases and user stories are developed, preliminary definition of the test cases should be occurring. Use cases often have several scenarios or versions. Test conditions should be defined that test all of these variations of the use case. If possible, test data can also be identified and built during the life of the project. This activity of building test data can be a user activity that runs concurrently with the development by the project team. Here's a sample test case list maintained in a spreadsheet. It identifies specifications, use cases, descriptions, test conditions, and expected outcomes. Managing and conducting the user acceptance test is much like a mini project in and of itself. A plan needs to be developed of how and when the testing will be done. Usually it is a set of tests that run over a period of time rather than one large single test. As before the integration test, a log must be kept of the results, especially the errors and fixes. Fixing errors found in the UAT is often a more complex effort because the error may be more severe and may affect several parts of the software. Some tests may depend on the results of other tests. Errors in later tests may require fixing and rerunning of earlier tests. For example, one test may be the creation of a month-end reports and month-end data. However, errors may be caused by daily transactions being processed erroneously. To fix the test, the daily test must first be fixed, then rerun, and then the month-end test can be rerun. And finally, here is an example of a user acceptance test log. In this case, we have taken the list of test cases that was built earlier and expanded it to include test results. Since one test case may require many tests, this example includes both more columns and more rows than the list of test cases we saw earlier. This log includes a specification ID, a use case identifier, a description, a detailed list of steps required to do the test, and the expected outcome. To run the test, the name of the tester is added along with the date the test was run. This example also includes a short description of the acceptance criteria. Finally, the status of the test case and listing of any outstanding errors that still need to be fixed will be included. A separate error log would track the errors and the work required to get them fixed and retested. As you can see, software testing is an important part of the development of a new system. These 4 types of tests, unit test, integration test, system test, and user acceptance test, should always be included as part of the project plan.